This rocket was created to answer the greatest challenge of the 20th century.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
I thought he was nuts. Technically, it was unbelievable.
There was going to be some serious problems on the way.
Reaching the moon will require a rocket of immense power. The mighty Saturn V.
This is a kind of power that you really cannot wrap your brain around.
To succeed, those involved will push engineering to the limit. They must overcome catastrophic failures.
There were massive problems with it that just were overwhelming.
And do it all within a decade. The goal, to build a rocket to send men to the moon. This is the story of the unsung heroes who built the Saturn V. December the 21st, 1968. Astronauts Frank Borman, Bill Anders, and Jim Lovell prepare to embark on a daring mission. They hope to make history by becoming the first humans to leave Earth and orbit the moon. That means risking their lives on board the first manned launch of the giant Saturn V.
We weren't going just to Earth orbit. We were going to the moon and back, 240,000 miles away.
Engineers have built a rocket weighing almost 3 million kilograms and containing over 3 million parts.
15, 14, 13, 12, 11.
If we had a failure, the damage can be overwhelming, and of course the crew's chance of survival is very minimal.
10, 9, we have ignition sequence start. The engines are on. 4, 3, 2, 1, 0. We have
The story of the Saturn V begins here in Huntsville, Alabama. In the 1950s, the city becomes home to a group of German engineers with a specialist skill: rocketry. During the Second World War, they are responsible for developing the V-2 rocket, the world's first liquid-propelled missile. They're led by the charismatic Wernher von Braun. But when Nazi Germany collapses, von Braun and his team surrender and are eventually brought to Huntsville to work on America's fledgling rocket program. For 12 years, they design rockets for military use, including the Redstone and Jupiter. Then, on October the 4th, 1957, the Soviets launch Sputnik 1, the world's first satellite. The space race has begun, and the USA is trailing. For rocket engineers like Don Binns, it's a bitter blow.
I remember you'd listen to Sputnik going around and going beep, 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 and it says, gosh, they beat us, and we'll have to really get our nose to the grindstone and move ahead and see if we can't catch up.
Fire command, fire command,
In 1958, von Braun's team successfully launch America's first satellite, Explorer 1, on board their Juno rocket. But von Braun is targeting a much bigger goal, and he believes he has the team to achieve it. Among them is Army engineer Jim Odom.
Dr. von Braun was one of the most remarkable men I've ever known. He was a a great leader. He was a very good engineer. And the team that he brought over here was absolutely outstanding.
Von Braun's team have been developing a pioneering series of liquid-propelled rockets called Saturn.
Von Braun always had his eye on bigger and bigger booster rockets that could launch larger and larger payloads into space. And he tried to solve that problem by taking smaller rockets and clustering them together. And that was the basis for the very early Saturn rockets.
April 1961, the Soviets launched the first man into orbit, Yuri Gagarin. For President John F. Kennedy, it's the final straw. He ups the stakes dramatically for America's rocket engineers.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space.
Don Binns and his colleagues are taken aback.
When I heard him make that announcement, we all watched it on TV and thought he was nuts. I mean, it's an amazing challenge. Technically, it was unbelievable.
I couldn't believe it. I could not believe it. We just needed someone to step up and say, let's go to the moon, because we were competing big time with the Russians.
But in my judgment,
Kennedy believed in us. In fact, he came to the Cape. Von Braun took President around, showed him the Saturn being tested.
Von Braun comes face to face with the man who set this seemingly impossible goal.
And the question he asked Von Braun was, are we going to beat the Russians to the moon? Von Braun said, yes, Mr. President, we're going to beat the Russians to the moon, and we're going to do it within the time frame you set. End of conversation.
This is the challenge Von Braun has been waiting for. And teams of engineers across America begin work on a mighty moon rocket.
So there were several different approaches, and each one has some technical disadvantages and technical advantages. And I would say Von Braun was probably the primary influence on what was actually selected.
The initial plan is to use a method called direct ascent. Assemble an enormous rocket and fly directly to the moon. Then, land a large spacecraft on the lunar surface before blasting off and returning directly to Earth. It seems simple enough, on paper. But engineers soon realize that building such a giant rocket by the end of the decade simply isn't feasible. Von Braun favors a different method, but finally decides on a technique known as lunar orbit rendezvous. Head to the moon with a smaller spacecraft, one that shuttles the astronauts to and from the lunar surface, while a mothership waits in lunar orbit. The final element is a rocket, powerful enough to take men to the moon.
And this is what we call the Saturn V. And the takeoff weight of this monstrous rocket will be about 6 million pounds, or 3,000 tons.
At the Davidson Center in Huntsville, the rocket's huge size can be fully appreciated. This is one of the 3 Saturn V's, painstakingly restored to a pristine condition by the Smithsonian National Air and Space Museum. They're the largest artifacts in the institution's collection. After a multi-million-dollar restoration project, they now take pride of place at displays in Houston, Huntsville, and at the Kennedy Space Center in Florida. Looking at them, it's possible to understand a key engineering principle Von Braun uses to create such a powerful rocket. The Saturn V isn't one rocket, it's 3, stacked on top of each other, known as stages.
Staging was a big deal in rocketry.
Stage 1 will use a cluster of 5 giant F1 engines to lift the 2,800-ton rocket to a height of 68 kilometers before separating.
The booster drops away, and then the second stage ignites.
Stage 2 will use 5 smaller J2 engines, boosting the rocket to 185 kilometers above the Earth.
And it drives the vehicle up near the edge of Earth orbit, and then the third stage kicks in.
Stage 3 has just 1 J2 engine.
And that puts the spacecraft and the third stage in orbit.
Before igniting a second time.
And the reigniting of that third stage was a big deal, because that puts you on a path to the moon.
But no rocket this big or powerful has ever been built before. Meeting Kennedy's deadline will push the rocket engineers to breaking point as they prepare to take on one of the greatest engineering challenges the world has ever seen. At 110.6 meters tall, even today, the mighty Saturn V rocket is still the largest rocket ever built. At the very heart of this beast is the F1 engine. Restored by the Smithsonian Institution, an example stands with other Apollo artifacts in the National Air and Space Museum in Washington, D.C. This fully renovated Saturn shows that the mighty rocket has a cluster of 5 F1 engines powering the first stage. Myron Pessin is one of the first stage engineers.
The biggest engines we had built up to that time were 200,000 pounds of thrust. This was 1.5 million pounds of thrust.
Each engine is 6 meters long, 3.6 meters across, and at around 9 tons is heavier than a school bus. 5 of these engines will fire the rocket and 3 astronauts to a height of 68 kilometers. So they must be rigorously tested and become man-rated.
To qualify the F1 engine, we call man-rated. We required 500 successful starts, which means you have to fire a lot of engines.
Test firing the cluster of 5 F1 engines presents a huge challenge. So engineers construct giant stands in Huntsville and at NASA's Mississippi test facilities on the banks of the Pearl River. Ron Teepool is involved in the test firings here in Huntsville.
The engines would have gone up on level 10, which is where those 2 holes are up there.
But to ensure the test stand isn't engulfed by searing rocket exhaust, engineers construct a giant deflector that can withstand the blast and direct it sideways.
They all 5 fired down through that aspirator, and the heat came out and deflected up about 500 feet out and 100 feet in the air. This deflector is cooled with water from a pump house that supports this test stand that has a capability of 280,000 gallons of water per minute.
April 1965. Engineers prepare to test fire the cluster of 5 F1 engines that will eventually power the Saturn V's first stage. Ed Buckby was NASA's press officer at the time.
I was called in by my boss, and he said the Life magazine is sending their photographer down to cover this test fire. He sets up his camera, and I said, you know, when it does ignite, you're going to see this huge ball of fire come out of the engines, and for a moment there won't be any noise, and all of a sudden the sound will hit you, and you're going to feel the vibration in your chest. The heat will come up your pants leg, and it's really rather scary when the first time you see one of these. He looked at me and said, "Young man, I've covered fires, tornadoes, wars, floods. I think I can handle this." I looked at the photographer. He had turned and was running across the field away from firing and test, and he never got one picture of the firing of the Saturn V booster.
The firing of these engines has a profound effect on the people living in neighboring Huntsville.
You could feel the ground vibrate some distance away, several miles away, I'm told. But if we were getting cloud cover, what would happen was the sound would go up, ricochet back down somewhere in the city. We would have people calling about windows broken, and you know, chandeliers shaking and coming apart.
But it's not just the windows that are shattering. Testing quickly uncovers a critical problem with the F01. One that's causing them to catastrophically disintegrate in seconds. Reaching the moon within the decade will remain a dream unless engineer Sonny Morea and his team can fix this flaw.
It was the program's showstopper. We would not have gone to the moon until we had a fix on that. We would not risk the astronauts on that vehicle when we had an engine that could blow up underneath them.
This became a big enough issue that we were concerned that we were going to impact the goal that was set to get to the moon in the decade. A team was put together to solve this problem that put the best minds together from around the world.
Sonny and his colleagues pinpoint the cause.
Well, combustion instability is a frequency that gets set up whenever anything burns. One of the ways to think about it is, if they're familiar with a candle burning in a room, you know that the candle flickers during the burning. That part of that flickering is the fact that it's unstable. The fire is unstable.
Like the candle, liquid propellants injected into the rocket chamber burn in an unstable way, creating powerful shock waves that rapidly oscillate until the force shakes the engine apart. Finding a solution will take America's top engineering minds the best part of 2 years.
Well, we went to a process that involved the use of baffles. Now, if you look at the face of the rocket engine in here, the face of the injector, you'll notice there are several compartments.
It works like this. Instead of the propellants entering the combustion chamber as regulated jets, the baffles interrupt the flow, subtly changing the way they ignite and reducing combustion instability. The first stage of the Saturn V is back on track. The second is taking shape on the other side of the country, at Seal Beach, California. But the engineers of North American aviation are way behind schedule.
The engineers who were building the second stage of the Saturn V found themselves in a kind of a squeeze. The first stage of the Saturn V had already been defined, and the third stage had also been designed before the second stage was even being developed. There was this constant battle to save weight, and the burden fell on the engineers who were designing the second stage.
The second stage must lift astronauts to a height of 185 kilometers. It has to be incredibly powerful, yet incredibly light. When complete, just 9% of its total weight is metal. 91% will be liquid propellants.
They had to find every way they could possibly think of to save weight in that stage, thinning the metal to the point where you really sort of worry, is this okay to do?
Many months are spent skimming every last gram of metal from stage 2, but it's still not enough. Engineers need to find another weight-saving solution, quickly.
The stroke of genius that they came up with was to do what was called the common bulkhead. If you look inside the second stage, you've got one tank for liquid oxygen and another tank for liquid hydrogen. And those two tanks take up a certain amount of space. Somebody realized, what if we could merge the two tanks together and create a single curved divider between them?
Having a common bulkhead reduces the height of the stage by almost 3 meters and sheds an impressive 3.6 tons of weight. It's a breakthrough for the Stage 2 engineers, but the schedule has slipped even further. Kennedy's deadline looks unachievable. And in November 1963, NASA ups the pressure. Against the wishes of von Braun, NASA shortens the schedule by removing several of the team's test launches.
Their concept was that you would launch the Saturn rocket with one live stage and 2 dummy stages on its first mission. If that worked, then the next time you would add a live second stage, you'd still have a dummy third stage. And if that worked, well, then you could launch all 3 stages as live stages.
But NASA now want to accelerate the launch schedule and test the live rockets all at once. The first batch of launches, Apollos 1, 2, 3, and 5, will use von Braun's smaller Saturn 1B rocket. The Saturn V's first unmanned flight will become Apollo 4, followed by a second unmanned launch, eventually called Apollo 6. The first Apollo astronauts will finally fly into Earth orbit on Apollo 7, and Apollo 8 will send men to orbit the moon for the very first time.
That was a big change for us here in Huntsville.
I thought, wow, this is going to be a lot of work, because that means that we're going to have to retest the stage, we're going to have to recertify it, make it man-rated. That was a big step forward, big step forward.
The clock is ticking, and the engineers are about to face disaster. Because the Saturn V is so large, Wernher von Braun and his team of rocket engineers design it to be made of 3 individual rockets, or stages, stacked on top of each other. This method of rocket building allows each stage to be built by a different aerospace company. But developing space technology means entering uncharted territory, and that can be risky. On January the 20th, 1967, the Douglas Aircraft Company is testing a 3rd stage prior to delivery to Cape Kennedy in Florida. Don Brinker is the man in charge.
It was the 3rd vehicle that was coming through our facility for a static firing. And that's when we loaded with propellants, and we go through a normal countdown. We were just getting ready, a few minutes from actually firing the stage.
Not only does the team lose an entire 3rd stage, but also the test stand suffers major damage. January the 27th, 1967. While engineers investigate the failure of Stage 3, preparations are made for Apollo 1. Slated to be the first manned Apollo mission, and the first in American history to carry 3 astronauts into space. Today, they're performing a routine countdown test.
We got 3 guys in a spacecraft, pressurized, suited up.
Across the country in California, Don Brinker is investigating his Stage 3 failure. He calls Cape Kennedy.
I was on the phone. We were talking about some of the things that we were looking at. And when he said, whoops, wait a minute, we got a problem. Something's going on here on the capsule. I can't talk to you anymore, and then blank, the phones went.
Unbeknownst to Don, during the call, a fire breaks out in the command module. Astronauts Gus Grissom, Ed White, and Roger Chaffee are killed. NASA concludes that the likely cause of the fire is faulty wiring, which created a spark. In the pressurized, oxygen-rich atmosphere of the command module, that spark became a raging fire in a matter of minutes. For all involved with Apollo, it's a brutal reminder: the smallest mistake can have devastating consequences.
I think the Apollo 1 fire was a shock to the guys that were close to the program. Again, they were so confident that these things were going to fly successfully.
The Apollo schedule slips again as NASA redoubles its efforts to improve safety. But for the engineers at Douglas, it's valuable time to understand what caused the catastrophic failure of their third stage. Like Apollo 1, the culprit is tiny: a weak solder weld on a helium tank. January 1967. The 3 stages of the first Saturn V are finally ready for assembly, and they arrive at Cape Kennedy. The challenge now is stacking them together. This is NASA's giant vehicle assembly building.
It's something like 525 feet tall. On occasion, it had its own weather. And there were times, and I saw myself, where there were actual clouds up there. All the stages came in through this south entrance. Part of the structure are the huge overhead cranes. They would handle several hundred tons with such intricacy. If you were lowering one of them and you touched an egg laying on the floor, it would sense that resistance before breaking the egg and stop.
The first Saturn V is assembled with breathtaking precision. But it's still a 5.6-kilometer drive to the launch site.
You open those big doors, those 450-foot doors, and roll that thing out. And now that's where you really drew a crowd.
This is the Crawler, the largest moving land vehicle ever built. It needs a team of 30 engineers and technicians to drive the 2,800-ton rocket and its launch tower on a road trip that lasts up to 12 hours to the furthest launch pad.
Houston flight now confirmed that they are go for the flight, as are all other aspects of the mission.
November the 9th, 1967. Apollo 4 is poised for the first unmanned launch of the Saturn V rocket. Engineers have spent millions of man-hours trying to meet Kennedy's deadline.
13. Ignition sequence starts. 5, 4, we have ignition. All engines are running. We have liftoff. We have
I think people were shocked with the power and the size of the Saturn V.
When you watch a Saturn V launch and realize that you've invested a part of your life, when you realize that it's really going to work, the gratification level is just outstanding.
After just 2.5 minutes, the first stage separates perfectly. The second stage takes over.
It's amazing how long you can hold your breath. We had ignition on the second stage, and ignition was good, and all our flight parameters were essentially perfect. After that, I was able to breathe again.
The spacecraft sends a constant stream of telemetry from thousands of individual readings to the flight directors and engineers. So far, it's working exactly as planned. Stage 3 ignites for the first time, and then for the second time. The mission is a complete success. The next Saturn V to be launched is Apollo 6, and after that, a manned Apollo 8. After today's launch, what could possibly go wrong?
This is Launch Control, T-minus 60 seconds and counting. First stage now pressurizing. We're coming up on the power transfer in a matter of seconds. Status board still indicates all is well.
5 months after the triumphant launch of Apollo 4, NASA prepares to bring President Kennedy's goal one step closer, with a second unmanned launch of the Saturn V, Apollo 6.
We have ignition sequence start. 6, 5, 4, 3, 2, 1, 0. We have commit. We have liftoff.
From the ground, it looks like a perfect launch.
We have cleared the tower. We have understand.
But the engineers know something is very wrong.
Pitch and roll program started. Our vehicle going now to an azimuth at 72.
Telemetry shows the rocket is vibrating in a violent up and down motion. It's known as the pogo problem.
I was told we had pogo. Pogo is a vertical oscillation, like a pogo stick.
Senior project engineer George Phelps has seen the pogo phenomenon before.
The pogo problem was very serious. The crew module, which was unmanned, experienced somewhere between 8 and 10 Gs of force, which, had there been crew aboard, could have killed them.
Next, stage 2. 5 minutes into its burn, there's more bad news. Engine number 2 begins to sputter and lose thrust. Then it shuts down altogether. Moments later, engine number 3 also shuts down.
We've lost engine 2 and engine 3.
The engineers can only watch in horror.
You've lost the engines? That's affirmative. Roger. Roger, we think we have 2 engines out. Don't get nervous. Roger, understand.
This stage is designed for 1 engine out, and there were 2 engines out.
The onboard computer tries to save the rocket.
The computer said, hey, you guys are in trouble. And it started to lift the vehicle back onto a vertical, more or less, vertical trajectory in order to get the 3rd stage and the crew module into orbit.
IGM seems to be bringing it in, flight. Roger. I'd say it's look and go, flight.
The team prepares to fire the 3rd stage engine for the 2nd time to send the command module on its designated trajectory. But it doesn't light. All 3 stages of the rocket have had critical problems that must be solved before it can fly again. The pogo problem with the 1st stage occurs when vibrations in the engine's thrust and combustion chambers match the natural vibration of the rocket in flight. They amplify each other and generate vibrations up and down the length of the rocket. Fortunately, the engineers discover a solution.
We put dampeners, a dampener, to absorb these vibrations, to make them safe. It doesn't get rid of them necessarily, but it minimizes them. It's like a shock absorber in your car.
But what went wrong with the 2nd and 3rd stages is a mystery. Telemetry reveals a sudden drop in fuel pressure on both engines. It's a telltale sign of a fuel leak. And it's traced to the failure of the engine's fuel igniter lines. But how could the engineers have missed this?
What they had missed with those J2 engines was that they were always being tested at sea level, where the moisture in the air would form a coating of ice around the propellant lines. And that actually ended up giving them extra resilience, extra strength against those powerful vibration forces. Once you got up above most of the atmosphere, there was no moisture, there was no ice, and it shook the heck out of those fuel lines and caused the problems.
If the Stage 2 and 3 J2 engines failed because of a weak pipe, why was the number 3 Stage 2 engine shut down?
As engineers, we pulled out all the block diagrams and the schematics and all that stuff. And a guy, he said, "You know what happened? I think those wires were crossed."
It's the simplest of mistakes. The wiring for engine 2 and engine 3 has been crossed, meaning the onboard computer sent a signal to shut down a perfectly healthy engine. Von Braun and his team have solved all the problems discovered by Apollo 6. October the 11th, 1968, NASA successfully launches Apollo 7. The first manned Apollo mission uses the smaller Saturn 1B rocket, placing its 3 astronauts in Earth orbit for 11 days. But Von Braun and his team are ready to go much further.
They understood their system. That's what allowed them to have the confidence to say, we're going to fly people on the third Saturn V, and once you put people on it, it doesn't matter whether you're going to go to Earth orbit or go to the moon. So let's go ahead and do it.
December the 21st, 1968. Astronauts Frank Borman, Bill Anders, and Jim Lovell are about to put their lives in the hands of the engineers who built the Saturn V, as they set out to become the first humans to fly around the moon.
Mark, T-minus 3 minutes and 30 seconds and counting. We have completed our communications checks with the Apollo 8 astronauts in the cabin, and the communications are go.
With the lessons learned from Apollo 6 and the successful first orbital flight of Apollo 7, NASA is ready to reach for the moon. Engineers can only sit and wait as the 3-man crew of Apollo 8 prepares to make history.
35 seconds and counting.
You know, this was the first time that we had huge turnout of the press. It was huge because, number one, first time we had a crew on the Saturn V ever. Secondly, we weren't going just to Earth orbit. We were going to the moon and back, 240,000 miles away.
12, 11, 10, 9. We have ignition sequence start. The engines are on. 4, 3, 2, 1, 0. We have commit. We have liftoff. We have cleared the tower.
Apollo 8, you're looking good.
As Apollo 8 thunders from the pad, its crew are the first to experience the awesome accelerating force of the mighty F1 engines.
Apollo 8 Houston, you are go for staging, over.
This time, both stages work perfectly.
Houston, I read Apollo 8. Yeah, we hear you loud and clear, Apollo 8. Okay, the first stage was very smooth, and this one is smoother. Understand, smooth and smoother. Looks good here.
Hearing the crew talk while on that rocket was really a moving experience. We had to keep telling ourselves, these guys are going to the moon. This rocket's taking these guys to the moon. And this had never happened before.
All 5 J2 engines fire flawlessly, accelerating the astronauts to almost 7 kilometers a second.
Apollo 8 Houston, your trajectory and guidance are go, over. Thank you, Michael. Yeah, you're looking real good, Frank. Very good.
We began to hear things like second stage shutdown. Okay, so you know second stage is shut down, and then they'd announce separation, third stage.
It actually is another one of those, whew, a sigh of relief.
S4B ignition. Guidance initiate.
After less than 2 Earth orbits, the engineers take another deep breath. It's time for the 3 men to be fired to the moon. The critical maneuver called Trans-Lunar Injection, or TLI.
We're sort of uptight because you have to accelerate the vehicle to 24,000 miles an hour to escape the gravitational forces of the Earth.
If the burn is a success, the path of humanity will change forever, as the crew of Apollo 8 become the first people to leave Earth's orbit.
Apollo 8, Houston. Go ahead, Houston. Apollo 8, you are go for TLI, over. Roger, understand, we're go for TLI.
The whole program now rests on this single engine burn.
Ignition, roger, ignition. Apollo 8, Houston, you're looking good here, right down the center line. Roger, Apollo 8. Okay, we got Seco right on the money. Roger, understand Seco.
That was a very profound moment because it was a major step in what we hoped was going to be space exploration.
As Apollo 8 and its crew head for the moon, the engineers on Earth who dedicated their lives to building the Saturn V reflect on a historic achievement.
I had given birth to that baby, and I remember, looking out at the pad and it was gone, and I thought, God, the love of my life has gone away from me, and she'll never come back.
The success of Apollo 8 paves the way for the first lunar landing, Apollo 11, in July 1969. The Saturn V engineers have beaten Kennedy's deadline. But the Saturn V's work isn't over. It successfully launches 7 more missions, 6 to the moon, as well as America's first space station, Skylab, in 1973. Today, the Saturn V rockets restored by the Smithsonian Institution draw large crowds. But preserving their engineering legacy has another important mission: to inspire a new generation of rocket engineers.
Pushing out into the solar system, not just to visit, but to stay. And last month, we launched a new spacecraft as part of a re-energized space program that will send American astronauts to Mars.
To achieve these bold ambitions requires the development of an extraordinary new rocket. Called the Space Launch System, or SLS for short, it will be even more powerful than the mighty Saturn V. R.H. Coates is one of the engineers working on its design.
The Space Launch System owes a great deal to the legacy of the Saturn V. One of the key enablers for the Saturn V was to utilize lightweight liquid hydrogen propellant. That legacy, that learning to design those high-performance upper stage engines also went into Space Launch System. We are definitely standing on the shoulders of giants by what we learned from the Saturn Apollo.
Only a few of the original engineers are left to appreciate the impact of their achievements as mankind continues its quest to break free from the confines of our planet and head out to the stars.